So far we've looked at using concentration, temperature and surface area to increase the speed or rate of a reaction. There's one other way we can do that, and that's using a catalyst. So for example, if I was to have hydrogen peroxide and I leave it for a while, it turns into water and oxygen. And if I balance that, it looks like that. I can speed this reaction up by including something else into the reaction, and it doesn't actually change what it is. Manganese dioxide, so manganese with 2 oxygens, will speed this reaction up, make it happen faster. It's what we call a catalyst. We start with manganese dioxide and we end up with manganese dioxide. So what is it actually doing? Well, if we recall, we can speed up a reaction by increasing the energy of the particles so that they've got more energy to react, increasing the speed, which actually effectively does the same thing, but it also means we get more collisions per second. We can increase the concentration, so there's more particles per cubic centimetre. But what we also can do is we can make sure that the collisions have the correct orientation. This means the particles that are going to react facing the right way. So a catalyst does none of these first 3 things. It doesn't work those ways at all. It doesn't change concentration, energy, speed, none of that. But what it does do is it puts the particles in the correct orientation. So what we have here are 2 hydrogen peroxide molecules colliding, and they have to collide in a particular way to make water and oxygen gas. The manganese dioxide holds those particles in place so that when they do collide, they're in the correct orientation to actually react. So what we say is that manganese dioxide, which is our catalyst, is not used up. That's a key point. It's if we start with 2 grams, we end up with 2 grams. Instead, it orients or places the reactants correctly so they can react. The outcome of this is that less energy is required, and that is why you get an increase of rate of reaction. The energy that this is called activation energy. So this reduces the activation energy required, so increases the reaction rate. It also means, if we're going to link to the collision theory, which we should be doing, that there is a higher probability or higher chance of the collisions between the particles being successful. So here we go. Being oriented correctly, there is a higher chance of the particles colliding successfully, and this is what we call a chemical reaction.